We'll start in about 1 minute. Today we'll start the test 1 review, and what we don't finish today we'll attempt to finish tomorrow. Remember, the last 10 minutes of this class or so, we'll exit this meeting and then I'll go to my office and start the Zoom meeting for the test orientation. Hey, number 1 on the test review. We have 2 parts, A and B. Solve for the variable in each equation. Hey, the equation in part A, first distribute multiplication by 2.2. So 2.2 times x is 2.2x. And 2.2 times 5 is 11. So we get 2.2x plus 11 equals x plus 8.6. We can subtract x from both sides. When we subtract 1x from both sides, we get 1.2x plus 11 equals 8.6. Then subtract 11 from both sides, and we get 1.2x equals 2.4. And when you divide both sides by 1.2, we get x equals 2. And the next problem in part B, solve this equation for y. 6y minus 2 over 2 equals 9y minus 6 over 7 plus 2. We could start by simplifying the left-hand side. If we divide every term by 2, we just get 3y minus 1 equals 9y minus 6 over 7 plus 2. And then we can subtract 2 from both sides. When we subtract 2 from both sides, we get 3y minus 3 equals 9y minus 6, all divided by 7. And then multiply both sides by 7. If you multiply both sides by 7, the left-hand side will become 21y minus 21. And the right-hand side, when you multiply that by 7, you get 9y minus 6. Okay, then subtract 9y from both sides. 21y minus 9y is 12y. So 12y minus 21 equals negative 6. And then add 21 to both sides. We get 12y equals 15. And then divide both sides by 12. Y equals 15 twelfths. And then in lowest terms, that's 5 fourths. Okay, in problem number 2, The hypotenuse of a right triangle has length 13, and one of the legs has length 12. Find the length of the second leg. If you want to draw a right triangle, you can. Label the hypotenuse as having length 13, and one of the legs has length 12. And we'll use x to represent the length of the second leg, and we want to find what the value of x is. Okay, so apply the Pythagorean theorem. We square the length of the hypotenuse, and we set that equal to the sum of the squares of the lengths of the two legs. So 13 squared equals 12 squared plus x squared. 13 squared is 169. 12 squared is 144. And we get this equation. 169 equals 144 plus x squared. Then subtract 144 from both sides. 169 minus 144 is 25. And if x squared is 25, the value of x that we want is positive 5. So the length of the second leg is 5 units, whatever the units happen to be. And in problem 3, solve the formula a equals 1/2 b times h for b. So I'll rewrite that formula, a equals 1/2 times b times h. On the right-hand side, we have a coefficient of 1/2. So if we multiply both sides by 2, we get 2a equals b times h, because 2 times 1/2 is 1. And then divide both sides by h. And we get 2 times a divided by h equals b. In the second part, it says find the value of b if the value of a is 24 and the value of h is 16. So there's one of two ways you can go about it. You can use the original formula, replace a with 24 and replace h with 16, do the arithmetic and solve for b. Or another alternative is use the result from the first part. Use this equation. If you're not very confident in your solution to the first part, you can always use the original formula. But I'll go ahead and use 2a over h equals b. Replace a with 24. So in the numerator, we have 2 times 24. And we're dividing that by h, which is 16. 2 times 24 is 48. And 48 divided by 16 is 3. So the value of b is 3. Okay, number 4. The perimeter of a triangle is 49 inches. The second side is twice as long as the first side. And the third side is 5 inches longer than the first side. Find the lengths of all 3 sides. If it helps, you can draw a triangle. So the second side is described in terms of the first side, and the third side is described in terms of the first side. So I'm going to label the first side. Well, we could argue about which one is the first side. I just picked this side to represent the first side. And so this first side has length x. And I'll suppose that this side over here is the second side. You don't have to do all of this labeling. I'm just doing it here just in case there's any question about which side is which. Okay, so the second side is twice as long as the first side. If the first side is x unit, or I guess we're measuring in inches. If the first side is x inches and the second side is twice as long as the first side, then the second side is 2 times x inches. And the third side is 5 inches longer than the first side. So the third side is x plus 5 inches. The perimeter of the triangle is 49 inches. So if we just add the 3 sides, 2x plus x plus x plus 5, this is the perimeter, and we're told that the perimeter is 49 inches. We solve this equation for x. 2x plus x plus x plus 5 is 4x plus 5 equals 49. Subtract 5 from both sides, 4x equals 44. And then x equals 11 inches. Okay, so this is find the lengths of all 3 sides. So the first side is 11 inches. The second side is 2 times 11 inches, or 22 inches. And then the third side is 11 plus 5 inches, or 16 inches. Okay, problem number 5. Solve the formula f equals 9/5 times c plus 32 for c. So we can solve this in 2 steps. I'll rewrite the formula here. F equals 9/5 times c plus 32. So we want to solve for c, so step 1, we can subtract 32 from both sides. So we get f minus 32 equals 9/5 times c. And then multiply every term on both sides by the reciprocal of 9/5. So in other words, multiply both sides by 5/9. So 5/9 times the quantity f minus 32 in parentheses. And 5/9 times 9/5 is just 1, and 1 times c is c. And then the second part, find the value of c when the value of f is 27. So using this formula, we can replace f with 27. So c is equal to 5/9 times 27 minus 32. 27 minus 32 is -5, so we get 5/9 times -5. And then 5/9 times -5 is -25/9. Okay, we'll leave the value of c as an improper fraction, -25/9. In problem 6, we have, this time we begin with the formula c equals 5/9 times the quantity f minus 32. Solve for f. Since 5/9 is a factor, a constant factor on the right-hand side, we can begin by multiplying both sides by the reciprocal of 5/9, which is 9/5. Multiply both sides by 9/5. We get 9/5 times c equals 9/5 times 5/9, which is 1, and 1 times f minus 32 is f minus 32. And then lastly, add 32 to both sides. So we get 9/5 times c plus 32 equals f. Okay, for the second part, find the value of f when c is 14. So once again, we have two options. We can use the original formula, replace c with 14, and then solve for f. Or we can use this equation that's already solved for f and just replace c with 14. So let's use the bottom equation, replace c with 14. So 9/5 times 14 plus 32 equals f. 9 times 14 is 126. So 126 divided by 5 plus 32. And that's equal to f. And 126 divided by 5 is 25.2. So 25.2, whoops, I don't need a division bar. 25.2 plus 32 equals f. And then when we add those numbers, we get 57.2. So the value of f is 57.2. Okay, the next page solve the compound inequality and write the solution in interval notation. Okay, so the solution to this compound inequality are all of the real numbers that we can replace x with, where either the left hand, the inequality on the left side, is true, or the inequality on the right hand side is true. Okay, so let's solve the one on the left first. Begin by subtracting 1 from both sides. So we get 1/2 x is greater than 1. Let's go ahead and solve this one. If x plus 16 is less than 12, then x is less than -4. And then there's one more step for the one on the left. 1/2 x is greater than 1. Multiply both sides by 2. We get x is greater than 2. or x is less than negative 4. So if it helps, you can sketch a graph of this. So plot the numbers negative 4 and positive 2. So x is a solution if x is greater than 2 or if x is less than negative 4. It's true that x cannot be both of those at the same time, but the compound inequality says or. X can be greater than 2, that's a solution, or if not, it could be less than negative 4. The only restrictions are the numbers that are between negative 4 and 2. So the interval notation, this part of the number line is from negative infinity to negative 4 parenthesis, and then we use the union symbol. The other part of the number line is parenthesis 2 comma infinity. So incidentally, even though the algebraic notation is not requested as an answer, this part is the algebraic notation. And this is the integral notation. Okay, the next problem, this is another compound inequality, but this time it says negative 2y is less than 12 and 2y plus 3 is less than negative 3. So this means that if y is a solution, then that number has to satisfy both of the conditions. Okay, so we'll solve each of these individually, but we remember that they are, it's a compound inequality with the word and. Okay, on the left-hand side, negative 2y is less than 12. We divide both sides by negative 2. And since we're dividing by negative 2, we switch the inequality from less than to greater than. 12 divided by negative 2 is negative 6. Okay, then put the word and in here to remind you, and then we'll solve this inequality. 2y plus 3 is less than negative 3. Subtract 3 from both sides. We get 2y is less than negative 6. Okay, so y is greater than negative 6, and when we solve this for y, we get y is less than negative 3. Okay, so a number is a solution, y is a solution, if that number satisfies both conditions at the same time. So y has to be greater than negative 6, and at the same time it has to be less than negative 3. So graphically, what does that mean? On the number line, negative 6 is to the left of negative 3. Okay, so y is a solution if it's greater than negative 6, and less than -3. So only the numbers that are strictly between -6 and -3 are solutions. The interval notation for this is parenthesis -6, comma, -3, parenthesis. The algebraic notation. Well, you could argue that this is the algebraic notation, but this can be written more concisely. So the way that we would want to write the algebraic notation is, well, we can use the graph as a guide. If y is in this interval, then -6 is less than y, which is less than -3. Okay, so this up here, this is the interval notation, and this is the algebraic notation. Okay, number 9, solve the absolute value equations. Okay, when we solve an absolute value equation, we want it to be in standard form, which this one is. That means that the absolute value part is by itself on one side of the equation. So our first step, after it's in standard form, is to write two equations without absolute values. So one equation without absolute values is just -2m plus 5 equals 3. The other equation without absolute values is -2m plus 5 equals -3. That is just an application of the definition of the absolute value. And then we solve each of those equations individually. -2m plus 5 equals 3, subtract 5 from both sides. We get -2m equals -2. Then divide both sides by -2, we get m equals +1. Solve the other equation for m. Subtract 5, -2m plus 5 equals -3. Subtract 5 from both sides, we get -2m equals -8. Then divide both sides by -2, and we get m equals +4. The two solutions are m equals 1 and m equals 4. So the directions don't say to use set bracket notation. So we'll just say m equals 1, m equals 4. Okay, part B, the absolute value of 3n plus 7 equals the absolute value of 6n minus 5. Okay, we want to write two equations without absolute values. Okay, so if the absolute value of 3n plus 7 is equal to the absolute value of 6n minus 5, then there's two possibilities. The two numbers can be the same number. 3n plus 7 could be equal to 6n minus 5 if they have the same absolute value. Or one number, 3n plus 7, is equal to the negative of the other number, the negative of the quantity 6n minus 5. So once again, we're just applying the definition of the absolute value. Solve each of those for n. So on this equation on the left, we can do a couple of things in the same step. We can subtract 3n from both sides and also add 5 to both sides. So we're going to subtract 3n from both sides and add 5 to both sides. We'll get 12 equals 3n. And then divide both sides by 3, we get n equals 4. That's one of the solutions. For the other equation, we'll distribute multiplication by -1. So we get negative 6n plus 5. And we can do a couple of things in the next step. We can add 6n to both sides and also subtract 7 from both sides. So adding 6n to both sides, we get 9n on the left-hand side. Subtracting 7 from both sides, we get -2 on the right-hand side. And then lastly, divide both sides by 9. We get n equals -2/9. And number 10, solve the absolute value inequalities. Write the solutions in interval notation. Okay, the one on the left, the absolute value of 3x minus 8 is greater than 1. So we want to write two inequalities without absolute values. So one of them is going to be 3x minus 8 is greater than 1. The other one is going to be 3x minus 8 is less than -1. And we solve each of those. So in this case, the word or is going to separate these two inequalities. So is it clear why we're using the word or? So just think of the 3x minus 8. Just think of that as a number, because that's what it represents. If the absolute value of a number is greater than 1, then where could that number be? If its distance from 0 is greater than 1, it can either be to the right of 1 on the number line, or it could be to the left of -1 on the number line. Right? If it can't get closer to 0 than 1, then it has to stay away from that. It's either going to be to the right of 1, that means it's greater than 1, or it's going to be less than -1, which is the same as to the left of -1. Okay, then we solve each of those separated by or. Add 8 to both sides, we get 3x is greater than 9. And then or subtract this, or add 8 to both sides of this, we get or 3x is less than 7. Then divide both sides by 3. 3x greater than 9, that means x is greater than 3. And then divide both sides of this by 3, we get x is less than 7/3. Okay, so graphically, 7/3 is to the left of 3. So x is greater than 3. means x could be to the right of 3 on the number line, or x is less than 7/3, which means that x could be to the left of 7/3. And so the interval notation, I'll write it up here where I have some room. Parenthesis, negative infinity, comma, 7/3, union, parenthesis, 3, comma, infinity. This is the interval notation. Okay, the next one, the absolute value of negative 2y minus 5 minus 3 is less than or equal to 4. The first thing to do is write it in standard form. So that means the absolute value of negative 2y minus 5 is less than or equal to 7. From here, we want to write two inequalities without absolute values. So think about what this is saying. Think of negative 2y minus 5 as a number. If the absolute value of a number is less than or equal to 7, then where must that number be? It must be between negative 7 and 7, and including the endpoints, negative 7 and 7. Okay, so one inequality without absolute values is just negative 2y minus 5 is less than or equal to 7. This time we're using the word and then the other inequality is negative 2y minus 5 is greater than or equal to negative 7. Then we solve each of those for y. If negative 2y minus 5 is less than or equal to 7, add 5 to both sides. We get negative 2y is less than or equal to 12. And then on the other one, and negative 2y minus 5 is greater than or equal to negative 7. Add 5 to both sides. We get negative 2y is greater than or equal to negative 2. And in each of those, we have to divide both sides by negative 2. If negative 2y is less than or equal to 12, then y is greater than or equal to negative 6. Remember to switch the inequality. And on the right-hand side, divide both sides by negative 2. And negative 2y greater than or equal to negative 2 is equivalent to y is less than or equal to positive 1. Okay, so on the number line, negative 6 is to the left of 1. So y is greater than or equal to negative 6. So from negative 6 and to the right, and y is less than or equal to positive 1. So graphically, that's what the solution looks like. The integral notation is bracket negative 6 comma 1 bracket. This is the interval notation. Okay, we'll do the next two. These are sort of like special cases. Let's just think about what these are saying. The absolute value of 2x plus 4 is greater than negative 6. Well, the absolute value of a real number that's represented by 2x plus 4 is always greater than a negative number, right? There are no exceptions. So this has every real number as a solution. So all real numbers are solutions. So in interval notation, the solution set is parenthesis negative infinity, comma, infinity. Okay, the other one, part B, the absolute value of 4y minus 5 is less than or equal to negative 4. So what about this one? Well, the absolute value of a real number is either positive or 0. A positive number is never less than or equal to a negative number. And 0 is not less than or equal to a negative number. So this one has no solution. So we write the empty set. This is the symbol for the empty set. You don't have to write the words, the empty set. I'm just reminding you of what the notation is for the empty set. Okay, let's conclude the meeting for today and join the Zoom meeting. It will take me 2 or 3 minutes to get to my office and start the Zoom meeting. So in the Zoom meeting, I'll take attendance over there. So that's all for today here.